Okay. Hello, everyone. I welcome you all on Data Phoenix webinar. Today with us, Kacper Łukawski. He's developer advocate at Qdrant. And today we will speak about best practices for building LLMs-based application. You can ask your question in the chat on YouTube stream, and write also your comments. And I give the microphone to Kacper.
Thank you. Yeah, thanks a lot for the invitation. This is really cool to present here today on Data Phoenix webinar. And as mentioned, we are going to speak about building LLM-based applications. And when I say LLM-based applications, I do not mean any kind of Streamlit-based demo that you can develop over the weekend, but a fully flexed application that might be run in production and serve to multiple users. Because that's completely different story. If you just want to create a prototype, you require different tools than for a real application serving any kind of traffic. So today we are going to review some of the most popular libraries or frameworks available for building LLM-based applications. And this is the full agenda. So we are basically going to review LangChain, Llama Index, and Haystack, the top 3 most popular libraries available out there. I'm going to speak about the differences between them, some different concepts and different ways how they actually handle the same tasks. Then we are going to review the toolkit that you may need for making some prototypes or experiments, and then move to productionizing LLMs. As already said, this is completely different story. So we'll review some challenges that you may face while implementing this kind of applications. And at the end, I would also like to share our story, because we built a system using LLM that is serving a specific purpose in our community. And I would like to share some lessons learned during this process. But let's start with LLM frameworks and LangChain, which is probably the fastest growing project of the previous year, and also this one. LangChain is a fully flexed framework that allows you to iterate very quickly, because it exposes multiple different providers, dozens of different tools which are already integrated. So you just need to choose wisely which one you want to use, and then build a very simple wrapper around them. So this is fine. LangChain is fully driven by the community. There are lots of contributors from external companies as well, including me, because I was responsible for making the integration with Qdrant. We were one of the first vector stores integrated with LangChain. And this is currently the most popular framework that provides you with multiple different ways of implementing even complex chains. So, because that's where the name comes from. And the main entity in LangChain is document, and document consists of the content and some metadata information stored along with the content. So basically, the documents might be created on your own, but they are also quite often loaded from some external sources using doc stores, document stores, and document loaders. And one of the examples of document loaders is unstructured HTML loader that takes an HTML document and split it into chunks. So they are those chunks are then useful for some upstreaming tasks in the whole pipeline that you build. So there are lots of different data loaders available, which are specific for HTML data in general, but also for some specific formats used to export the data from different sources. And think about Gmail for exporting the email messages from your inbox, Slack, Discord, whatever you can actually imagine. LangChain community is really active, and there are different vendors providing their own integrations just to be present in the library itself, just because it's so hot topic nowadays. So document is the most basic entity, fairly simple, and LangChain is all about the texts. There are also some neural models available in a LangChain, two different kinds. First of all, we have embedding models. So those kind of models are used to convert your texts into their vector representation. And those vector representations have this useful property that two different vectors should be close in terms of some sort of distance function, usually cosine distance function or Euclidean one. And two vectors are close to each other if they represent a similar idea, a similar text. And this similarity covers not only the words which were used in a particular text, but also the semantic meaning. And that's why we call this semantic search. We call this approach semantic search. So there are multiple providers of embeddings implemented in LangChain. Companies like OpenAI or Cohere that expose those embedding models as API, but also some local models that you can run on your own environment, not necessarily locals, but ones that you can host on your own. Think about Hugging Face embeddings, etc. There are also LLMs, so large language models. Those models are used not to generate some different representations, some different vector representations, but to generate some text instead. So LLM takes a prompt as an input and produces the output based on that prompt. So one of the most popular examples are OpenAI models, but Cohere is another provider here. But you can also use some models that you can host on your own, like GPT-4All, that exposes multiple different models with the same interface. And the huge advantage of using LangChain is that it provides you with unified interface for both embeddings and LLM models. And if you want to just experiment with different configurations, like a particular embedding model and a different LLM, this is fairly easy to be implemented with LangChain, because you can just choose a different class, different implementation, and switch it in your application. Okay, there's also a prompt, which is an input to LLM, and the prompt may have some variables to be provided, some context that we put into the prompt. So this is called prompt template. Actually, this is the same concept in LangChain. Prompt and prompt template. This is just an alias. But basically, this prompt contain some placeholders that we fill later on while processing. There are also tools, and tools are really useful because those are actually those pieces of the library that allows you to speak to the world. So different tools have different responsibilities. These are just a few examples of those. There is a Python REPL tool that allows you to actually run a piece of code produced by a large language model. YouTube search tool that allows to search for some YouTube videos, if that's an intention of the prompt sent to the LLM. But you can also search for some flights between two particular cities using Amadeus flight search tool. Those are pretty interesting tools. There are many others, and the library provides you with dozens of different tools to be used, and every single tool has to have a description provided, and this description is used by an agent that we built to choose a proper tool for given task, and that's pretty cool because that allows you to speak with external services. And tool is not an agent. That is a question that I can see right now. Tool is not an agent. Agent is something that uses tools, but not it. I will just switch to describe what is the meaning of the agent in a few slides. And the next thing is the things are retrievers and vector stores. Actually, this is pretty important because LLM is a system that was trained on some data, and it's pretty useful to generate some text, but it has no clue about a particular knowledge that you may have, like the documents of your company, or even the Slack conversations, the private Slack conversations that we could possibly fed into the LLM, but they were not used during the training phase, so it cannot really tell anything about this particular data. So this is why we need some external sources, and vector stores are used in order to store the vector representations generated by the embedding models. And those vector stores are also useful to retrieve some documents which might be relevant in a specific case. So vector stores expose a specific interface that allow to perform semantic search over their content. And this is pretty commonly used with LLM-based applications just to bring some interesting content into the context of the prompt that we sent into the LLM. I will describe that process later on. And there are also retrievers. And the retrievers are a more general term. Retrievers are used to just take some kind of data, not necessarily using semantic search, but also keyword-based search. And actually, you can also provide some different tools like SQL databases to be used as retrievers, but also knowledge graphs or graphs in general. So this is like a generic term used for systems that can return documents based on query. There are also chains, and chains are really exciting because chains actually allow us to pipeline a set of actions that should be performed one after another. And this is where the name of the library comes from, because LangChain is all about building chains of actions performed to solve a particular problem. And question answering is one of the most popular issues or problems solved with LangChain. And this is a graph describing how this kind of process may look like if you decided to use vector store, because question answering is a problem where in which we want to provide an exact answer based on the user question. And those user questions are not necessarily asked about word in general, about the data that was used by a particular large language model during the training phase, but usually about the data that we may have, those documents, which are private in our company and were not included in the training phase, have to be queryable for the large language model in order to use it somehow. So this is a typical chain. So whenever our user sends a question to the system, LangChain, first of all, vectorizes this question, then uses the vectorized question to retrieve some candidates, some semantically similar documents that can possibly answer that particular question. And those documents that were retrieved from vector store, in this example from Qdrant, are then sent as a content of the prompt. So our original prompt is not not just the original question, but a request to answer that question based on the context information. And this context information is a set of documents which might be relevant to answer it. So this is pretty common, and this is a set of action to be performed one after another. So chain is a linear process, but chains may also have a mechanism called memory. This is a short-term memory that allows the system to keep an information about the previous state of that particular chain, and that actually makes our chain stateful, so they can keep information between different runs. And there is an agent. An agent is not a tool, as already mentioned, but agent uses both LLMs and tools in order to perform some actions. Not necessarily tools, but in general, agent is a system that uses LLM to perform some reasoning. So agent will typically query our LLM multiple times just to extract some responses, and those responses will be then used to select an action, a chain, or maybe a tool that it should use in order to answer that particular questions. So there is a loop of reasoning scheme. So agent iteratively performs some actions based on the outputs of the LLM. So this might be pretty complex, but LangChain already has some agents implemented in place. So you can just create an agent, set some particular tools, and it will be choosing those tools and launch those tools based on the user prompt. So this is what agent is all about. Imagine you wanted to build an intelligent agent that will be acting as some sort of assistant. So it will be looking for the cheapest flight between two cities, and it will be also acting as some sort of search mechanism. It will be searching over the web. So that might be actually pretty useful if you have some tasks that you perform quite often. It will be just automating the stuff that you do. So an agent will receive a set of tools with their descriptions included. So for example, it will include the tool that allows to browse the web, use Google search engine, and another tool, the Amadeus flight search tool, that will allow you to query for the flights in a particular date and cities. So that actually this agent will receive both tools, both objects that allows to query those services, together with a description of when to use each of those tools. So probably Google search will be used as some sort of fallback if none of the other tools is chosen as a preferred one. But this is like where the intelligence of those systems comes from, because they are able to analyze given prompt and choose the proper action based on this prompt, and choose a proper tool to handle that. And the good thing about LangChain is that it actually has everything already implemented in place. It has all the prompts pre-configured, so you can actually set up a pretty simple application, even a complex application, quite easily if you want to do that. But if you want to change the defaults, things start to be a bit more complicated. Let's just have a look at one of the prompts which is already built into LangChain to see what I mean. This is one of the prompts. I just put a link to the repository, and this is basically a pretty long prompt that is being sent if you decide to use so-called staff chain. As you may see, there are even some specific questions, some documents and answer. This is actually some kind of instruction that we give to the large language model with some sort of expectations of how we want it to behave in some specific scenarios. There is a question, what did the president say about Michael Jackson? And there is much information put into the prompt, and it might be simply be used by the model as a context information. That happens quite often. I also had that issue that the answers of the model were including some information about Michael Jackson, even though I didn't include that name in the prompt. And I was quite surprised to see that happening. And that's why we also need to care about the prompts that we send to LLMs, even if we just simply experiment with LangChain. So if you experience any kind of problems or unexpected outputs, that might be one of the reasons. And overall, LangChain is a giant library integrating dozens of document loaders, vector stores, and since it's growing so fast, the interfaces are still a subject of change, and it's also quite hard to be up to date with everything. So this is they're really developing it with an enormous pace, and that has some drawbacks because this is still not stable. At least not that stable as I would expect it to be. But there's also another tool, Llama Index, that started almost in the same time. And Llama Index, formerly called GPT Index, is another framework which is more focused on ingesting the data, structuring the data, accessing private data in some domain-specific tasks. This is the second most popular framework, around 20,000 GitHub stars in that very moment, and it focuses more on the input data. It has some different concepts. So it also has a concept of a document, but document here is something more general because document is as well, it's self-explanatory probably, but document may contain multiple data, and document is an abstraction over some data source. Let's say you have a PDF file or a row from your SQL database. This is, in a nutshell, a document. And document may consist of multiple nodes. As you may see at this example, let's say this is a website that has multiple paragraphs. It has an image. It has some sort of media like video. It may also consist of some tables. And node is just a chunk of a document, a chunk that should semantically has meaning. And those nodes might be created by a user, directly by the user, but they are quite typically extracted automatically with some utility methods provided in Llama Index. Documents might be loaded with data connectors. They are exposed in Llama Hub, so they are not a part of the library itself. Actually, not all of them are a part of the core library, but they are just loaded from external sources. So there is a huge difference comparing to LangChain because Llama Index wanted to keep it simple. I mean, the core library, and there are not that many dependencies required just to support an enormous number of data connectors. So they're currently being separated. Historically, they were also included. But this is quite cool. I think this is also pretty important because that allows you to keep the dependencies limited, and usually you won't be loading the data from all the possible data sources. So each document has metadata information that might be a file name, and single node might be a text chunk, but also image and actually anything else. So Llama Index is not limited to text only. So there are lots of concepts which are quite similar to LangChain. For example, there are also LLMs. There are also embedding models. This is pretty interesting because Llama Index and LangChain are, I thought they would be competitors, but they are also integrated with each other. So you can reuse some embedding models, for example, from LangChain. And this is cool because they are not reinventing the wheel again. They are providing some basic support, but if you want to use some other embedding models, you can freely use those which are available in LangChain. And that makes Llama Index fairly simple and limits the number of the dependencies and things to simply maintain. There are also vector stores and retrievers. They have similar meaning, tools and agents. So there is not much different. But Llama Index is a bit simpler comparing to LangChain. It focuses more on some transformations on the data and building whole processes, but not on providing you the integration with all the possible tools available out there. An interesting piece, which is there is no one-to-one counterpart in LangChain, is query engine or chat engine that allows you to speak to your data in chat-like or query-like manner. And as said, Llama Index is quite similar to LangChain, but it's simpler, and it is primarily designed to bring private data into LLMs. So it's not a framework that covers all the steps, but it's still pretty interesting to use it. It's probably also a bit faster to start working with because there are way less concepts to understand. And another library which is also popular, and that's probably the oldest one, at least on the list that we are looking at today, is HiStack, created by DeepSet. So this is a framework to really build LLM-based, but not only LLM-based applications. HiStack was on the market even a few years ago. And HiStack provides you a way to build so-called pipelines. But previously it was rather focused on semantic search, but not only. Right now they are integrating LLMs quite heavily. I would say this is the most major tool out of those three, just because it has been used by multiple companies even before the whole LLM revolution started. So HiStack also has a concept of a document. Each document might have a different type. They support texts, tables, and images. And each document also has an ID and some metadata if you want. But a single document is not limited to text, so it is more similar to Llama Index than to LangChain. But overall, the idea keeps the same. Okay, so this is how it looks like in HiStack. As you may see, there is also a place for embedding, because embeddings are quite often used in those kind of applications. And scores, because if you use some classification models or any kind of model that scores your documents, this might be also pretty useful to be stored along with your documents. So this is cool. And HiStack has a concept of document store, and document store is just a place, a storage layer that keeps your data somewhere else, so you don't keep everything in memory. That allows to use like bigger data sets than just while using in-memory storage. And it might be an SQL database, it might be a vector search engine like Qdrant, but actually that has to be a sort of tool that allows you to select some relevant documents based on some criteria. And Qdrant document store is one of the options. This QR code points to Qdrant HiStack repository that we maintain, because with LangChain and Llama Index, Qdrant integration is built into the core of the libraries. Here, HiStack decided to choose a different path, and they want their providers to support and maintain the integrations by themselves. I would say this is an interesting approach, just because we are able to manage the integration, and whenever we have a new feature that might be relevant for a specific integration, we can do that on our own. So this process is also interesting. If you want to test it out, here is a QR code. And here is how we built application with HiStack. HiStack has an idea of building so-called pipelines, which are not necessarily linear, but they're rather built as some sort of DAG, directed acyclic graph. So every single step performed by this pipeline is a node, and the node processes given input and produces some sort of output. As I said, there might be some decision components included, so this doesn't have to be linear. We can just choose a different path based on, for example, content type of the file that we process. And Highstack was historically providing the same functionality, building pipelines, for example, for semantic search, but also for keyword-based search, for classification. They have some components that perform text-to-speech translations and many, many more, actually. There are also some transformation based on files. And this is historically what Highstack was offering. Right now, they also included LLMs, which is pretty interesting because everybody wants to use LLMs right now. And that fits quite well to their proposed structure of the applications. However, they also introduced a new concept, which is similar to LangChain and Llama Index, and this is an agent that is actually built in the same way like it was built with those libraries that we spoke about just a while before. This is how a pipeline is different from agent. I really like those pictures. I just took them from Deepset blog. Deepset, the company behind Highstack. And pipeline is a fairly simple process that takes query and provides answer. But with agent, things are not that easy because agents perform those reasoning loop, this reasoning scheme. So they try to provide the final answer, but here the processing is rather iterative. So they might be choosing different tools to extract some some useful pieces of information. They might be also using some pipelines probably under the hood to perform some more complex processing. But basically, they have some observation, they have some thoughts, and they choose tools based on those thoughts just to provide the final answer. So this is more complex. I really liked this post, so I just put a link to it. Really worth reading. And the main difference that I see right now, actually, when it comes to some design choices, is that Highstack is not focusing on the input data that much, comparing to Llama Index or LangChain. It has support of some basic file formats and built-in web crawler, for example, but not that much like LangChain, for example. They follow a minimalist approach they personally like, and since you might have different data sources, you probably better know how to integrate them with your pipelines than they may do. So you are free to choose your data sources and just integrate them into your Highstack based application. Somehow bring your own data in your own way. We'll probably reuse some already existing tools for that. So they don't have to maintain a huge collection of data connectors that may simply change over time. So I like this minimalist approach, I have to say. And this is it when it comes to LLM frameworks or libraries. Now let's speak about prototyping, because that's where LLM applications usually start with. So prototyping is a bit different than building real applications, let's say. Prototyping for me is something that you build during a hackathon or over a weekend or as a side project just to demonstrate how things might be implemented. And for that, you usually need some components that work out of the box just to speed this up, just to make sure that you do not waste time on integrating some data sources, for example, if you use some standard ones like SQL databases. So if you build some demos, you usually want to have some integrations already in place so you can bring the data without writing the whole process. That's what integrations are actually what we all hate when it comes to building apps, right? That's where all the troubles come from. And if you want to experiment with different models, then you probably want to have them already implemented. If you use OpenAI or Cohere embeddings served over an API, it would be great to have them already with the same interface, so you can just choose a different provider to switch that seamlessly in your application. And the same goes for LLMs. If you want to try different ones, let's say you want to experiment with GPT-4, but then you want to switch to a private model, this is also great to have them already implemented with the same interface. And that's where LangChain, Llama Index, and HiStack shine. And you may also want to have different storage, different vector stores available. If you just experiment on your local machine, you may want to have in-memory vector store or a local mode for your vector store, just to not send your data to cloud, just not to pay for the service itself. It's way easier just to remove a single directory on your laptop than to set up and spin up a new system somewhere else, or even pay for some cloud services. And the most important part is that you need an easy way to glue this all up. So you really want to keep things simple, and that's where those libraries are really useful for. So both LangChain and Llama Index, as well as HiStack, provide you with this easy way of implementing those demos. So you can write a single file with, I don't know, a few dozens of lines of the code, and that will be a working system that you can expose as some sort of Streamlit applications. But this Streamlit is not a tool that you would be using for a production system. Actually, nobody serves Streamlit apps and nobody exposes them as a production application, just because it's hard to maintain them. It's hard to modify, and usually we are solving some issues with those kind of libraries that would be easily solvable if we decided to use pure, I don't know, HTML or React application, if you know those tools. Well, this is actually what all those libraries are really useful for, building demos and prototyping. But not all of them are really major enough to be able to handle a production load, for example, because production challenges are a bit different. If you build a prototype, it's still fine to just cherry pick some of the results just to present that it might be working in some specific scenarios. But overall, when you decide to go to production, you need to care about the output quality. You need to care about the responses generated by your model, by your large language model. You need to care about the quality of your embeddings, because some of them might be capturing the relationship in your data, or might be representing them in a better way, and that influences the precision of your application, the quality overall. There are various ways of how to do that, but none of those libraries actually care much about quality. So we need some different tools to do that still. There is a great blog post by Eugene Yan about serving LLMs, and this particular paragraph is all about measuring the performance of models. I really encourage you to have a look. But the short gut feeling is that it's worth choosing an LLM wisely, just because some LLMs might be biased and might be not working for a specific use case, or they might be working quite well when you just prototype, but then when you experience some inputs that you haven't really foreseen, you may simply get into troubles because the model might be biased, or might be just not accurate enough to produce some meaningful results. But there is also another thing. The outputs of LLMs are usually in the form of a free text. But in order to serve that in production, we usually force the model to produce some structured output. Let's say we ask the model to produce an output as a JSON document with some specific keys and values, so we can actually reuse that in our further processing. So that's a quite common strategy, And there is a cool library called guardrails that allows you to specify some quality checks over the outputs of LLMs. So this is really cool. It has an integration with LangChain as far as I know, but you may also easily integrate that with any application. This is still an alpha release, so please expect that it might be not stable yet, but it performs some sort of validation over the LLM outputs and allows you to fail to provide an explanation to your end user that we couldn't provide an answer for that specific task just because some criteria were not met. This is cool, and this is something that we need to care about to avoid cases where LLM outputs might be simply dangerous for our users, for example. And there is also quite well-known issue with LLMs. They have a tendency to confabulate, to hallucinate. And hallucination is a response that cannot be justified by the input data. So it cannot be justified by the training data of the model, but also cannot be justified by the information that we put into the prompt, because those are actually two sources that an LLM might be using to provide the output. We cannot avoid them like 100% of times, but we can reduce the number of hallucinations by performing so-called retrieval augmented generation. So large language models were trained to solve some language tasks like summarize this text or extract names of people from that piece of text. But we shouldn't be relying on their internal knowledge. They were for sure trained on Wikipedia, for example, so they have some sort of understanding of the basic concepts. And if you ask them what is the capital city of the US, they should be answering that easily. But if you ask a question about the data that the model hasn't seen before, you might be expecting two scenarios. It will just deny to answer your question or provide you an answer which is non-factual. And that's a high risk. And that's why we shouldn't be forcing our LLMs to solve knowledge-oriented tasks, but instead we should be converting those knowledge-oriented tasks into language tasks. And that's the short story. So instead of asking, how can I create Qdrant collection? I should I should put a different prompt, answer the question using a provided context. And I should put a context. I don't know, if I want to answer this particular question, I should probably put some documents, put some paragraphs from the Qdrant documentation that might be answering that particular questions. And this is solved by semantic search. And Qdrant is one of the tools, one of the vector stores that can perform the semantic search on your behalf. This context has to be extracted from our knowledge base, and it has to be done in an automated way to keep things efficient. We won't be providing this context manually. That's not the purpose of the whole LLM revolution, right? So we need to perform semantic search, and we need to use this original question, how can I create Qdrant collection, vectorize it, and use this vector to find some relevant documents that we indexed before. And this is quite a common scenario to use a vector store under the hood. So then your application will be taking an original question of a user, looking for some relevant documents, and putting those documents into the context of the prompt with this conversion from knowledge-oriented task into language task. That's what retrieval augmented generation is all about. And in order to serve semantic search in production, you might be interested to use Qdrant, a vector database, aka vector search engine. We are already integrated with those LLM frameworks. We have some additional filtering criteria, so we can not only perform semantic search, but let's say if you want to look for a book similar to given question given summary, let's say I want to find a book which is about, I don't know, Superman or whatever you can imagine, You can also perform some additional filtering that the book shouldn't be older than 20 years, for example. So this cannot be captured by the vectors themselves, so you need this additional filtering criteria. Good thing about Qdrant is that you can experiment even locally without spinning a single Docker container if you use Python SDK, or if you use any of those LLM frameworks because they are Python libraries. You can freely use the in-memory mode of Qdrant. So all the data will be stored either in memory or on your local disk. And that allows you to build fast prototypes, and then switch, if you decide that the project might be successful, switch to Docker container to store more data and get better performance, or even use Qdrant Cloud offering. We have a free trial if you are interested. So this is pretty cool to testing things easily. And there is no difference if you use any of those LLMs. You just configure Qdrant a bit differently, but that works out of the box. So you can switch between in-memory, Docker containers, and Qdrant Cloud seamlessly. So there are also some issues with semantic search. Like, it might be inefficient if you serve, I don't know, billions of vectors. The search may take a while. And if you are on a budget in terms of memory and computation, you might be wondering how to speed things up. You might be tweaking the HNSW. HNSW is an algorithm that we use to keep things performant. You may be just tweaking the parameters to reduce the memory footprint and reduce the time spent on search or indexing. You may be also interested to see scalar and product quantization. Both are mechanisms to reduce the memory footprint, and scalar quantization may also speed things up. This QR code actually links to our scalar quantization article. This is a preferred way of how to reduce the memory usage and keep the search precision quite on a very similar level. So scalar quantization may help reduce the memory usage by up to 4 times, and product quantization even up to 64 times, if I remember correctly. But scalar quantization is a preferred way to not lose much of the accuracy. But there is another issue with building applications using LLMs that is not that often discussed. There are different scenarios. There are I/O bound and CPU bound applications. I/O bound applications are those that need some time to wait until some operations are finished. Let's say you communicate with a database. You send some requests. Those are sent over the network, and then you wait for the response. From the perspective of your user, those might be just small, like some milliseconds. But if you write Python applications and you use those external services, you waste some time just to wait for those responses, and your CPU is just actively waiting for a response. And that's quite often the case when we use some external services like OpenAI or Cohere for LLMs and embeddings. We call those services and we wait for the response. And that's why we lose some computational power. So if you use any of those tools, you might be glad to have a look at asynchronous programming, which is quite commonly used in web development nowadays. If you use Fast API, for example, you may be writing your code asynchronously. And this is also possible with some of those libraries that I mentioned. So, for example, LangChain provides you with, it's not fully covered yet, but they are making huge progress, and Qdrant is the only vector store that allows you to perform your operations in fully asynchronous way. Llama Index has also introduced asynchronous operations. So this is how your application will look like if you decide to use async Python. You would be just putting additional keyword like await for every Qdrant-based operation. This is also integrated into the chains, and that makes it really powerful because we are not actively waiting for the response. There is also another thing if you use some external services for LLMs and embeddings. And this is all about costs and time. LLMs are slow, not only expensive, and it's way better to store your prompts, to cache them somewhere. So in case you receive the same prompt a few times, you can reuse the cached version, and that not only reduces the latency but also the cost, because LLMs are based on tokens that you send and receive from them. So it's way better to keep things on your end in a different systems, so you don't really need to requery the LLM or embedding model with the same request. So let's say you want to keep your LLMs or embeddings. So you receive some sort of input into the system. That might be a question that your user asks. This is sent to your application, and your application uses this text input to find if it has a similar entry in the cache mechanism. And for the cache mechanism, you can freely use a vector store or Qdrant as well. You can have a separate collection in which you will be storing those previous inputs. And in case of LLMs, you might be just simply vectorizing your text inputs and comparing the embedding with those ones that you already have. And if the similarity is high enough, you may be just simply serving the same answer of your LLM, because we shouldn't be expecting that it will be that much different. And the same goes for embeddings. If we have our text input that we vectorize through some embedding model, then we can make this step optional, just because we can have another collection in which we will be storing the text inputs. And if there was the same text inputs provider before, we can simply extract the embedding from that collection and avoid calling those probably expensive services. So that acts as a caching mechanism, and it's possible to be implemented also with Qdrant vector store. So this is it. That reduces the latency and costs with LLM-based applications. And there were also some attempts that I was pretty excited about, that people were producing some queries that they were expecting to receive in a particular application. Let's say you run an e-commerce business, and some of your search queries that your users use while looking for some particular items might be occurring quite often. So then if you just vectorize them beforehand, you will have an efficient cache mechanism for that. But there are also some other challenges that we usually have while building any kind of application, not only LLM-based one. And there are things related to deployment. Those kind of systems are not always like a core of the whole application, but they might be serving a specific purpose in a whole system, probably a bigger one. Your system will have some different functionalities, like some sort of authentication, some sort of integration with relational database to choose some items. And your LLM subsystem will be just a small part of the whole app. That's why we should not be building our apps with LLM already in mind and structure all the application around it, but LLMs should be rather covered with some sort of abstractions that will fit our architecture in an easy way. And providing that sort of functionality as a REST API is a common approach, and the only tool that allows you doing that out of the box is Haystack. Actually, the only one that I mentioned today. So if you want to build a pipeline, you can easily expose that with Haystack. It will build a fast API application around your pipeline, so you can easily integrate this microservice with all the other systems that you may have in the whole stack. So that's really cool about Haystack. That's why I really encourage you to have a closer look at it, because I think this is underrated tool right now. And production systems are rarely a console application, so LLMs are not the core of that. And there is another story about monitoring our systems, something that we quite often forget, because our LLM-based applications are prone to errors. And having some sort of monitoring system around that, at least technical monitoring, so we will be notified about any sort of exceptions that were thrown during the application was running. This is something really cool to have. This is quite often the case with LangChain. People are complaining that its built-in login mechanism is not the best one, to say that at least, and it's quite hard to determine what was happening inside out of the logs. So that's another story. Logging, extracting the meaningful logs from LLM-based applications is crucial, just in order to keep the quality of it. But also, LLM-based application is, at the end of the day, just another type of application, and we should be handling them in a similar way. I really encourage you to have a look at Sentry, which is quite a common choice for monitoring at least application bugs. So those exceptions, so we will get notified whenever you have an exception thrown. Not only, but that will give you an overview of what is happening inside, and that pretty well integrates with Python applications, and not only, but also human feedback, even either explicit or implicit or explicit, giving our users a way to express how they feel about the outputs of this kind of systems is really crucial in order to keep their quality. And this is also a pretty interesting information if you ever wanted to fine-tune the LLM for your own purposes. This is also doable with some services like Cohere. They provide you a way to fine-tune the model for your own purposes, but also for those private or self-hosted models, this is also pretty useful. This human feedback might be used as a ground truth in some further processing, just to know that a particular answer was not that relevant. And I would also like to share some lessons learned when we implemented our own Discord bot. I was playing with that for a few weeks, and actually this is still in progress, so hopefully we are going to open source the project pretty soon. So please stay tuned and watch our social media, LinkedIn and Twitter profiles, because that's hopefully gonna be announced quite soon. And our Discord bot was implemented to serve a specific purpose. We have a Discord community that is actually the way of helping out our users to build some cool applications with Qdrant included. We usually answer some questions, help users to start using that, or help them configure the system if they struggle with anything. This is a QR code that links to our Discord community. And we decided to build a bot just because some of the questions were asked multiple times. So we built a Discord bot that is indexing the messages which are being sent to all the Discord channels that we have. And those messages are then being used in this retrieval augmented generation. So we extract some similar messages from the past and try to build an answer based on that context. So this is how it looks like right now. You can it's open. You can ask those questions using direct messages. So I wanted to know how to enable the scalar quantization for a collection in Qdrant. So that's something I already mentioned. That's a technique to improve the performance of search and reduce the memory footprint. This is still not finished. However, if you ever implemented a Discord board, you already know that the Discord SDK is fully asynchronous. And if you just put synchronous code inside, you may simply get in troubles. Thus, we have to implement it fully asynchronously. So if we send a request to an external API, we use Cohere embeddings and Cohere LLM systems. So we are sending an asynchronous request to those services. And instead of actively waiting for the response, we can handle another user. And that's where the difference between prototype and production system comes from. This bot is able to serve multiple users at once. and thanks for that, just answer multiple questions without spinning, I don't know, multiple copies of the same system. That's what asynchronous operations are really useful for. And since we decided to build that, we had to implement Qdrant as an asynchronous vector store in one of the libraries, and LangChain was the first choice just because it was the most popular one. So we started working on it. That's also why Qdrant is the only fully asynchronous vector store available. So we built that. There are still some challenges that we want to solve before we make it public, because as you may imagine, our users are sometimes sending some code that doesn't work. And how can we differentiate between the real answers and the problems reported by the users? If we just put some problems into that, into the context, then we may end up with answering some in a wrong way just because the context was wrong, right? So that's why we are not only providing an answer, but we are also providing links to those discussions that might be relevant. So people can not rely only on the answers, but also on some specific threats that might be meaningful in a similar scenario. So we still try to figure out how to exclude this noise from signal, how to exclude false from true answers, and how to promote correct answers in that specific scenario. But this is still something that we need to figure out on our own. If you have an idea, please just drop me a message. I'm happy to discuss that. But hopefully we are going to publish that, open source it soon, so you can reuse that freely for your specific use cases. And we built that with LangChain. Initially, we built that with LangChain. However, at some point, we decided we need to switch to some custom code. And this is why. Here, I have two outputs of the profiler. This is a Python profiler. And I just launched the same application using LangChain, and it took about 16 seconds to answer a specific question using LangChain. But then when I decided to recreate the same process, but using my own code with hard-coded embeddings model, but the same one, hard-coded LLM using directly the Cohere API, I was able to reduce the time to around 6 seconds. So it's almost 3 times faster, just because I was already sure that I want to use those particular services. And that's why I really encourage you to build your LLM-based applications without the vendor lock, because this is cool. We were able to fully experiment, to fully take it from the beginning to the very end with LangChain. But then if you want to serve that in production and receive multiple queries at the same time, possibly, then it won't scale at all, because it just wastes too much time on some additional things that happen in the meantime. And we should probably handle the LLM-based applications in exactly the same way like we handle different databases, different data sources, and build some abstraction over the whole LLM part of our application, which is usually not the core of the whole system. And that's what we did with our Discord bot. We built some sort of abstraction over the agent, and there were actually two different methods that you can call on a particular agent. You can either index some messages, put them somewhere. In our case, this is obviously a vector store, Qdrant vector store. And there is another method to respond to a particular message, to create an answer that will be relevant for a given question. And we built different implementations around it. So we built a LangChain agent, actually different kinds of LangChain agents, because we were experimenting with different types of chain, querying LLM just once or multiple times. Also, we were able to switch the LLM because we were configuring that from outside. We were able to choose different LLM, different embeddings model. We were able to provide some additional details or whatever you can imagine. But we also did the same for the other providers. We were able to build an agent with the same interface like expected, using Llama index, using Haystack, and also our custom code, because at some point we already made a decision. We want to use this specific vendor for our embeddings and the same one for large language model. And that turned out to be the most efficient way of implementing that. So this is the story of our bot. We shouldn't be really focusing on a particular library. It's still not established there is no consensus on which one is the best. Probably you might be just enjoying Haystack or Llama Index more than LangChain, or the other way around. But definitely, if you build a production grade application, you should be still focusing on the architecture, and this is how it should be built. There should be an abstraction, but none of these libraries should be probably integrated directly into the core system without having a way to switch it easily. If you have any questions, I would be happy to answer them. But if we do not manage to answer them right now, feel free to reach me anytime using my Twitter or LinkedIn. I would be happy to discuss any issues you may be having with LLMs or vector stores, whatever you work with. Thank you very much.
Yeah, thank you for so good overview of different tools. It was really cool. We have several questions. Let's try to answer for them. First, question about how to connect your private data with LLM.
Yeah, definitely. That's what all those libraries do under the hood. So the question is that we would need to go over all the data. Actually, it's not true. If we use those tools properly, our LLM should be able to produce, I don't know, even an SQL query, because it will have all the information about the tables that we have under the hood, and it should be able to build a query that can be launched on this system easily. Of course, there is a room for errors here. Like if you let your LLM to run any kind of query and you have some competitors using your tool, they may be simply performing some SQL injection or deleting all the data. So there have to be some restrictions created. But those tools are capable of creating a query and sending it to the tool in a proper way. So they can convert your query into an SQL query and then extract the meaningful data. So you won't be going over the data again and again, but instead you will be just accessing a subset of it. That's also what happens with vector stores. We use embeddings to find some relevant items. Hope that answers the question.
Yeah, more one question about fine-tuning LLM for specific domain.
Yeah, okay. So I have to admit, I have never fine-tuned an LLM. I was mostly reading some articles or papers about fine-tuning that. That seems like a valid approach, but I cannot say if that's the best way of doing that. Maybe, but sorry, I cannot answer. But I would be happy to just have a closer look, and we can maybe discuss that privately later on.
What about prompt engineering?
Okay. So prompt engineering is something that everybody is experimenting right now. I'm not going to pretend I'm an expert in that, but yeah, there are multiple ways of how to force our LLMs to behave exactly as we want them to, putting some roles and providing this context. And if you want to have this chain of thought, well, actually, that works pretty well with ChatGPT and GPT-4. That's what I was mostly experimenting with recently. If you ask them to produce this chain of thoughts, they will be simply producing a list of steps that should be taken in order to answer your query. In reality, they do not work like that. They won't be like making all those steps one after another. It's just an output of a possible way of solving the problem. But yeah, this is a cool example of how to make the system work in a way that we can at least see if the reasoning scheme was accurate in a specific scenario. This is pretty interesting. But I know that I also experimented with some other models in the recent days, and I know that doesn't work well with all of them. So that really is so this is really model dependent.
Good. Thank you, Kacper, for this more one time. Thank you for this amazing presentation. I think if we will have more questions, we will answer. Please not forget to subscribe to our YouTube channel, join to our Slack channel, and yeah, I will be happy to see you all guys on next week. We continue speaking about LLMs. So thank you for
Thank you
all
very much.
that you.
Yeah, I'm
Yeah,
also a member of the Slack community, so you can just drop me some messages here. I'm happy to answer all of them. Thank you very much.
yeah. Thank you. See you next week. Bye.